Section 6.1 is solving inequalities by addition and subtraction. This is going to be done exactly the same way we did with equations, but now we're talking about inequalities. So remember that when we have inequalities, we're talking about greater than and less than, or greater than and equal to with less than and equal to. So let's take a look. So the addition property of inequalities says that if any number is added to each side of a true inequality, whoops, that should be one word, the resulting inequality is also true. So for example, if I give you an inequality, t minus 45 is less than or equal to 13, if I add 45 to both sides, which is how I would solve an equation, I will get t is less than or equal to 58, and that is true. So we just have to plug in to see what happens. Now, if you are asked to graph the solution is all the numbers less than or equal to 58. So we would find 58 on the number line. If we wanted to graph t equals 58, we would put a solid dot there. Less than 58 means to the left. So that's the graph for our solution set. The book also talks about set notation, which looks like this. We use a bracket and we say the solution for t for all t less than or equal to 58. We'll talk about that when we get together in class, but there's a little bit of a preview of that. So if, for example, let's try another one. If I say 7 is less than x minus 4, again, we would add 4 to both sides, and we would get x is greater than 11. Now keep in mind that we're reading from the x to the left. So this says x is greater than 11. So our graph starting at 11 would be an open circle because x doesn't equal 11, it's only greater than 11, and to the right. How about this one? 14 is greater than x plus 3. So now we're going to subtract 3 from both sides, and again I get x is less than 11 this time. So 11, open circle, to the left. We'll do a few of these together, but when we have an equation with addition and subtraction, okay, oh, and I guess, you know what, I think I should have done the next slide first. Yeah, so the subtraction property just says that if any number is subtracted from each side of a true inequality, the resulting inequality is also true. So back to the last slide, this is an example of the subtraction property. Sorry about that. Which again is listed here. So figure that out, put it in some order for yourself. Let's do one more example of the subtraction property. So 12, let's do x plus 12 is less than or equal to 13. Subtracting 12 from both sides results in an equivalent expression. X is less than or equal to 1. So and equal to is a solids dot, and less than. Okay? So what happens if we have variables on both sides? So for variables on both sides, for example, 6x minus 1 is greater than 2x plus 3. So we're going to solve this just like we would if there was an equal sign there. Subtract 2x from both sides. Add 1 to both sides, and divide by 4. So our solution is x is greater than 1. Okay? So pretty simple, adding and subtracting. The only difference is we've thrown in an inequality symbol instead of an equation, and that will do it for us.